Hey students, in this video I'm going to go over the introduction to imaginary numbers. In this notes, we are going to just understand what are imaginary numbers. So an imaginary number is a number that is a product of a real number and the imaginary unit. So what that means is that the imaginary unit, kind of like the unit ones, tens, hundreds, we have the unit of I. And an imaginary number comes out from using that unit. So for example, I square is equal to -1. This is a fact that you need to just memorize. I square equals -1. Now, because I square equals -1, you can imply that I by itself equals square root of -1. And this comes from understanding that I square is equal to -1, and if we want to have I by itself, we got to cancel the square with square root. So if I draw a square root on the left side, I got to draw a square root on the right side. And the square root cancels the squaring, leaving this with I by itself equaling the square root of -1. So this is what's emphasized right here. So this is another fact because of the previous fact. So why is this important? We are going to be seeing imaginary numbers whenever we have square roots of negative numbers. So for example, we know that the square root of 16 equals 4. The reason why is because the square root of 16 is equal to square root of 4 times 4. And whenever we simplify radicals, if we have the same number on the inside of the radical twice, this is a group that will be taken out of the radical and placed on outside just the number that was in here twice. So it equals 4. And we can see this in the calculator with other examples. For example, if I type the square root of 5 times 5, because the square root is canceling 5 times 5, your answer is 5. We can also write square root of 5 times 5 as 5 squared. Square root of 5 squared. The square root cancels the squaring, and you're left with 5. So it's different ways to understand this, but basically whenever you have the number times itself, on the inside of the radical, it will come out to the outside of the radical to kind of look like this. If you have numbers on the inside other than 5, then those will be placed in here. If there's no number left, then basically that is deleted, and the answer is 5. Okay, so then if we now look at square root of -16, we can say that 4 times 4 is 16. But to get -16, you'll have to multiply times -1. So here, the 4 and 4 come out, and now we have 4 times the square root of -1. So because of what we learned up here, that the square root of -1 equals I, we can rewrite this square root of -1 to look like 4I. And that is the answer to square root of -16. Your calculator, if it's in the correct settings, double check. It will have to be settings, document settings, and right here where it says real or complex, we want to use not the real, that's just the numbers we've been using up to this point, but I need you to switch it to rectangular. That way we can have complex numbers be used. So for example, if I type now square root of -16, your answer will come out with a 4I. If I just type square root of 16, then it will just be the number 4. So the I appearing in the answer meant that you had a negative on the inside of the radical because of the -1. So taking that out will make us write that I on the answer. Okay, so here's a couple of examples that we did in class to practice that. We have a square root of 9, and we know that square root of 9 is 3 times 3. But now because it's -9, we're going to have a -1 included. The 3's are a pair that will come out. So we're going to have 3 square root of -1. And once again, the negative square root of -1 will be replaced by the number or the letter I. So the answer of square root of -9 is 3i. Then we have another example, square root of -25. For this one, same thing, we can go through this process. Or the other process that I saw some students do is remove the negative from the inside by writing I on the outside. And then now focusing on square root of 25. So the square root of 25 is 5 times 5. So we're going to have I square root of 5 times 5, which means that these two 5's come out and there's nothing left on the inside. So we just write 5i. So again, these are two different ways to get to the answer. Most of the students are choosing to do this, remove the negative by putting an I outside, and then just focusing on the number. So for example, this one, we see a -72, so right away we know that that negative will be an I on the outside, and we can focus on square root of 72. Now, if we recall, there are perfect squares, 1, 4, 9, 16, 25, 36, 49. All of those are perfect squares that will give you whole numbers as answers. If you have a square root like this one, 72, that means that it's in between 8 and 9, so the answer will be a decimal. If you use your calculator and you type square root of 72, you get a decimal, 8.48528, and it's not an exact value. So we don't want that. We want to write the radical version of square root of 72 to be exact and not a decimal. So what we're going to do is we're going to focus on 72. We're going to break down the number 72 into a prime factorization. One way to do that is by breaking down what are the factors of 72. Students may or may not know the factors off the top of their head. So I recommend that if you don't, you can always go by, okay, it's an even number, so we can divide by 2. And 72 divided by 2 is 36. So this is another method of breaking down the numbers all the way to primes. Divided by 2, divided by 3, just the basic numbers that we are used to. So 2 is a prime, I'm going to circle it. 36 is an even number, so I'm going to break that down again to 2 times 18. 2 is a prime, and then 18 can be broken down into 2 times 9, and then 9 could be broken down into 3 times 3. So these numbers that I circled are the prime factors of 72. So I can rewrite this as 2 times 2 times 2 times 3 times 3. And this is just to show that the square root of 72, which is what we just did right there, is the same as 2 times 2 times 2 times 3 times 3. So those decimals are the same, which we can imply that this is the same as that. So all these numbers multiplied together give us 72. Okay, there is a shortcut in the calculator that can give you those values. You can press menu, number, factor, and it's a program that allows you to type a number that you want to factor. And when you press enter, it gives you the prime factors. So notice that 2 to the third power is what we have right here. 2 times 2 times 2. And then 3 square is 3 times 3. So you can skip this part of prime factorization by hand if you would like to use a shortcut from the calculator to get these prime factors. What's important here is not this. What's important here is writing that 72 into the primes. So now we can take out the pairs, and this 2 comes out, this 3 comes out, and this 2 by itself on the inside. So when we rewrite this, we will have square root of 2 on the inside, and the 2 and the 3 come out. So 2, 3, and I are on the outside. 2 comes out, 3 comes out, an I is already on the outside. So this is then now a merge. 2 times 3 is 6. So the answer here is 6i square root of 2. Okay, so to verify this, I just showed to the students that you can always type on your calculator square root of 72, because we're going to verify that the answer that we got is correct. So square root of 72 is that number. And again, we didn't write the negative because we just want to double check what square root of 72 is. That negative not being typed means that we are not going to type the I. We're just going to type 6 square root of 2. And notice that the decimal that we get for square root of 72 is the same decimal we get for 6 square root of 2, which we are to imply that this is the same as that. So therefore our answer is 6i square root of 72, square root of 2. And the I is just saying that it used to have a negative on the inside. Here's another example. Square root of negative 175. I'm going to use the calculator shortcut just to jump into the factors right away. Menu, number, factor, 175. According to this, it is 5 squared times 7, which means that I'm going to write 5 times 5 times 7. And then that negative will be written as an I on the outside. Now we see that the 5s are a pair that comes out. So we're going to write I, well actually it's not I5, so this is the wrong way to write it. We're going to write 5i square root of 7. So 5 is now a coefficient of I, and then you have square root of 7. There's nothing else to break down, so this is the answer. And again, you can verify this by typing square root of 175. And that decimal should be the same as typing 5 square root of 7. So ignore the negative here, and ignore the I right there. So 5 square root of 7. Notice that they both are the same decimal, which means that these are the same value. Okay, one more example together. We have square root of negative 124 divided by 2. So here we're going to simplify the numerator first, and then we'll divide by 2. So negative is written as an I. I'm going to break down 124 into factors. So we're going to do menu, number, factor, 124. And it's 2 squared times 31, which means we're going to have 2 times 2 times 31. And you don't need the calculator for this. Like I said, you can always factor it by hand like we did right here. But because of time, I'm using the shortcut. These two are a pair, so that are going to come out. And you end up with 2i square root of 31. This is the numerator only, so you still have to write divide by 2, divide by 2. And then now, the division of 2 only applies to the coefficient that you have for I. So 2 divided by 2 equals 1, but we're not going to write 1i, because in algebra we don't write ones in front of variables. So I'm going to wipe that out. And only leave the I, and then have square root of 31 right next to that. So that is your answer, I square root of 31. If you're going to check in the calculator this is correct, you would again ignore the negative that's right there and just type square root of 124 divided by 2. So we're going to write square root 124 divided by 2. And then that decimal should be the same decimal as us typing this without the I. So we're just going to type square root of 31. Okay, notice it's the same decimal, and therefore these are the same value. And those are the examples that I am going to just explain for this topic. And if you want to practice, you have these examples to practice. And in the back, you have more. You have all these to practice. This at the bottom is a practice of what's next. So watch the next video for that. Okay, I hope this video helped you.